Good morning, ladies and gentlemen of Algebra 2 Honors. We've devoted today and next Monday for test preview. In addition to what we're going to go over today and Monday, there is a video that has this too. So I can give you a code to that at the end so you can do some extra review Monday night. And for those who aren't here, also. So we're going to go over some of these problems. The first one here is really, this is a recap of exercise we did earlier. In fact, if you go through your work that you've turned in already for this class, you will see this problem worked out, won't you? Someplace. So we can go over this pretty quickly. And it says graph the parent cubic function f of x equals x cubed and use the graph to answer each question. And so just like we did in class a couple weeks ago, if we mark in, we have 0, 0, and 1 cubed is 1, 2 cubed is 8. Okay, and then negative 1 cubed is negative 1, negative 2 cubed is negative 8. So we have this looking function right here, something like this. Not drawn very well, but I guess this is probably about as good as can be done. Something like this, right? So that's it. And state the function's domain and range. Where's going to be our domain for this thing? Negative infinity, hasta infinidad. Okay. I'm just going to write one version of the notation here. And range is going to be same. Domain range the same. And identify the function's end behavior. So as x approaches infinity, f of x approaches infinity also. And as x approaches negative infinity, f of x approaches also negative infinity. Okay. Identify the graph's x and y intercepts. So x-intercept is, sometimes you'll say 0. I like to, when I identify these, I like to put a full coordinate pair because that leaves less doubt in what your intentions are, right? Yeah. And then your y-intercept is going to be the exact same, right? Identify the intervals where the function has positive values and where it has negative values. So we say f of x is greater than 0 on what intervals? On what interval? 0, greater than 0, less than infinity. And then f of x is less than 0 on what interval? On interval from negative infinity, greater than negative infinity, to less than 0. Identify the intervals where the function is increasing and where it is decreasing. So f of x is increasing where? Always, yeah. And always you would articulate something like this on the full interval. So meaning on the interval of this right here. And where is the function decreasing? Yeah, so f of x, you can say increases nowhere, or you can say never or nowhere increases. Decrease, excuse me, yes, thank you, Ray. Decreases. Tell whether the function is even, odd, or neither explain. And here there's a correct answer given, odd. What is your explanation of that? What is your explanation of it? Yeah, one way that we've talked about is if the thing has 180-degree rotational symmetry, definition of odd, which is the case here, okay? And also there's a more academic way of describing it, like, I'll tell you what it is. It's, if I can remember it, f of equals negative f of x. I think that's how it goes. And you can graph these things and see what it is. So f of x equals negative f of x. So if you let I have to look that up because it's just a way of explaining it. You can look at it in a calculator pretty easily, like this. So if you put x cubed in here, and you go look at the table view, you will see this kind of symmetry here. Okay. So f of x equals negative f of x, f of negative x equals negative f of x. That's what it is. F of negative x equals negative f of x. That's how it works out. Okay. So f of, if you take the numbers negative, that would be just the same as turning these things negative down here. That's what we'll do. So, and then to describe the graph symmetry, symmetric about the origin, I also like to say, let me see how this comes on the screen here. Yeah, there it is. I also like to say 180-degree rotational symmetry. Because I think 180-degree rotational symmetry, to me, that's a better and more complete explanation than symmetric about the origin. To me, it's just, I don't know what it seems like to you. That's the way I like to explain it. Okay? Questions on this? And you remember going over this earlier? Anyone?
Yes.
Little Cheyenne remembers?
Yes.
Okay, Cheyenne remembers. Makes me feel better. All right. And what I did is this preview is taken from the actual test. So I go look at the actual test. What's going to be covered in that? So that's what we're looking at today. The graph of fx equals x cubed with 3 reference points is shown. Here we have reference point here, here, and here. What are the coordinates of a transformation of each point according to the transform function? Negative that minus that. So how do we do such a thing? What would be our strategy on this?
So we get right 3 and down 5.
Yeah, and so what I would do is I would do what Braden said. I'd say I'd go right 3. I'd start out like this, right 3, down 5. And so what we can do is we can take, and one way you can do this is take a table and just use a transformation with the table. So you have x, f of x, and you want to go ahead and change this into x g of x, right? Because that's what we're looking for. X g of x. And the first thing you do is go right 3. So if we take these reference point whose x input value is -1, 0, and 1, what do we do that's right 3 from here? What do these change to? 2, 3, and 4. Okay, now here's one thing you can do that is just going to nail down this thing right here, especially if you have a calculator, because you know you've changed your input values, right? So how can we just totally get this right and not have to do a whole lot more thinking about it? Yeah, your calculator. I'll show you probably what I think is the most efficient way to do that. So you go to your calculator and you go in here. What I'm going to do for my calculator too is I'm going to go ahead and go to table set, and I'm going to go ahead and change this to ask. Okay, you see that? You have your calculator. I'm looking around, not seeing. Randy has a calculator. Braden has a calculator. Kendall, do you have your calculator? Somewhere. Okay. And so the next thing I'm going to do is I'm going to go right here.
Mr. G, wouldn't you, there's a negative sign in front, so wouldn't you like reflect it as well?
Okay, you just, you need to give me a little time here. I'm going to answer your question. Well, that's actually a good question. Okay, I'm not a disrespect question. But I'm really, what I'm doing now is the answer to that question, essentially. Right, in a way. But you're right, you were right, okay? So Jose, you're 100% right. But I'm showing you how to really, how to automate this using a calculator, is what I'm doing. Because what you're going to do is you're going to let the calculator do that work for you. But you had to be able to do this, the way I'm doing it, you had to be able to recognize what Braden suggested, right? Which was 3 to the right. Okay, so let's continue with that. So we have negative out front. So we're going to go ahead and we're going to enter this as our function right here. All right, so let's do that. So we have negative, we have x minus 3 cubed, and which way are we translating this thing? Was it down 5 or up 5? Down 5. Okay, down 5. I forgot. Okay, so now we have this entered, right? And we could graph it like this, and we can see what it looks like, and what Jose mentioned is going to be true, just based graphically, right? But remember we moved those points? So 2, 3, 4, we can just put them in here. 2, 3, 4, and what do we have? We have our answers, don't we? So negative 4, negative 5, negative 6. So negative 4, negative 5, negative 6. So all we had to do was move these 3 to the right, and then we let the calculator do what? We let the calculator do the heavy lifting, right? And so after that, Jose, now Jose was 100% right again. I don't know if I can give him too much credit. But you see, Jose, that the calculator takes care of it for you from here? Okay? Yeah, we could go ahead and intellectualize it more than what, we could go ahead and take this center, move down at -3. We went down 5, so this thing went down 5 also. So we can move to the right, move down 5, and that's going to be this -1, -1. So we'll take that -1, subtract 5, but then we reflect it and all this kind of stuff. But to me, when you have a calculator in hand, that's the way to do it, right? You have any questions about this more? Okay, let's go ahead.
Should I wait for your phone?
All right. Next one, 3. We're going to describe how the graph of g of x is related to the graph of f of x equals x cubed. So we would say g of x is f of x what? Moved. Somebody said moved, right?
Translated.
You can say moved, translated,
Right.
slid, okay, everything, whatever it is, fill in the word. Translated is kind of the more classically, conventionally accepted word in algebra, but it'll be 3 units to the right. And then you can test your hypothesis with your calculator. Okay, so if you should happen to forget this, I think we've had enough experience. I think it's almost second nature to probably everybody in here, but, right? Questions on that one? Another word you could use, relocated, right? Relocated. There are other words too, I'm sure. Now 4, describe how the graph of g of x is related to the graph of f of x equals x cubed. So that's going to be g of x is f of x what? Okay, reflected across the x-axis. Okay, very good. Pen is a little glitchy across x-axis. Sometimes you'll hear people say reflected about the x-axis. All right, so, but this is definitely a right way. Anything else?
Very good.
And I heard Braden say vertically compressed. By a factor of 2/3. Okay, so that's going to be it. And again, you can test your hypothesis with a calculator, right? Okay. Next, 5, describe how the graph of g of x is related to the graph of f of x equals x cubed. What is this going to do? F of x is G of x is f of x. I got it backwards. Thank you. Let me write it down correctly. G of x is f of x. You see why that order is important? It's f of x. Okay, now what? F of x what? Okay, vertically stretched. You said by a factor of 5? Is that really stretched by a factor of 5?
No.
I'm getting something different. What is this stretched by a factor of?
Well, if you move it out a little bit.
Okay. How did that happen?
That is good to do. 5.
Yeah, what the reason that happened is because we have this thing, right? That's going to be equal to 125 x cubed. So you're vertically stretching by a factor of 125. So just be careful about that. So this is a bit of a trick question sort of thing, isn't it? It is, right?
Yeah.
Because I'm looking at the same thing, I'd say the same thing Haley said, if I didn't. Okay.
So in the, on question 2, if we moved it down, or we moved it to the right 3, does it not get affected by the cube there?
On number 3?
On number 2.
On number 2, the one you were talking about earlier? Well, yeah, what that does, it really does, but what you have is 1x. It's 1x, and what is 1 cubed? 1. So in this instance, you're not going to see, because 1 cubed is 1, so we just have that. Now,
But
if
it's negative 30, right?
Does
If-
it not get affected by the cube?
let's say we had negative 2x minus 3 cubed, right? Now, you're going to be affected by 2 cubed. But when it's 1, that doesn't enter into the deal.
Yeah, but the negative, but the minus 3, does not get affected?
Well, it'll affect this, because what it'll be, if you expanded it, you would have like, that would be negative 27, and then there'd be a binomial expansion of it all. Yeah, it would. This would be a binomial expansion. We could do that's a binomial. We could expand that according to the binomial expansion 1, 3, 3, 1, and all that. But
Instead of moving to the right 3, it moves to the right 27?
here, yeah, no, what it's going to do, this is going to move to the right. I'll show you how much this moves to the right here. I know what you're saying here, I think. If you set that equal to 0 here, then what you're going to have is 2x equals 3. And so what you're going to do is you have x is equal to 3 halves. So you're going to move to the right, in this instance, 3 halves because of that. Because if you solve for 0 and see where that is, you'll see this moves to the right 3 halves. And you can test it in the calculator. But what you're doing, Jose, you are introducing hypotheticals that aren't going to be relevant for this test review. Okay? That's right. No, but that's good. That's advanced thinking. What he's doing is that he's thinking like he's working ahead to pre-calculus next year. That's what Jose's doing. No, that's good. I mean, that's a good comment. Okay, and then what else? And translate 2 units down.
It would have been.
Okay?
To answer the question.
So on number 3, what did we move right 27?
No, 3 units.
I just got it.
So the cube doesn't matter unless the x is more than 1.
Yeah, that's,
Think about it like that.
Okay.
yeah, that's one way to think about it, Jose. That's a good way to think about it. But what it is, if you set this equal to 0, that's going to tell you what happens. If you set what's parenthesized equal to 0, that will explain what happens. And then you can test your hypothesis by graphing, right? Let me see where we are on this thing here. 6. Okay, let me see. We're on page 2. Okay. A cubic function with the general equation of h of x equals a times quantity x minus h cubed plus x is graphed below. Write a specific equation for g of x by identifying the values of the parameters from the reference point shown. Okay, so we're going to go ahead, I'm going to write just a standard form here. We're going to go ahead and see if we can work with it. Now we keep in mind that what do we have available to us also? We have a calculator in hand, right? So whatever deficiency we come with here, our calculator is going to be able to erase our misunderstandings or our deficiencies, right? So we're going to be okay. So let's not get all freaked out about this. So what do we know about this? Do we know from this what h and k are?
Yeah, negative or positive.
So let's go ahead and put what is h going to be equal to?
3.
Is h equal 3?
Negative.
H will be negative 3. And what is k equal to?
2.
K is equal to 2. How can you tell that? Okay, what you're doing is you're looking at this inflection point, because your inflection point is going to be it's what we looked at earlier here, didn't we? That's our point of inflection. And so we can recognize by what happens here, we're going from concave up to concave down. That's our point of inflection. So that's our h and k right there. So now, let's go ahead and substitute in here. Now we have h of x is equal to a times x minus negative 3, so that's going to be x what? Plus 3 cubed and plus 2. Okay, what next? Now how do we find what a is? By the reference points. So I want you to pick out a reference point for us to use here. So this one right here? Okay, so how would we how do we incorporate these values in here to find what a is?
Negative 1 equals.
So negative 1 equals a, negative 2 plus 3 cubed plus 2. All right? So we have negative 1 equals, what does this equal here? Negative 2 plus 3?
1.
That's 1. So 1a plus 2, so a is equal to,
And what about the cube?
yeah, so that's 1 cubed, so that became 1a. But yeah, so that's right. So your thought process is good. Don't forget, he says, forget about Q. Okay, that's the guy we want to have on our team to make sure we're not making a mistake, right? So it's kind of impossible. So what is A equal to? A is equal to -3. And so now we have what this is, right? So we have our full equation to be h of x is equal to -3 times quantity x plus 3 cubed plus 2. And so that's what it should be. And what's the very last thing we're going to do in this problem? What's the very last thing we're going to do in this problem? No. Okay, that's good. Box your answer right on the line. No, we're going to enter it in the calculator and see if those reference points are present as figured, right? Yeah. So you're going to do that, and so I want, when the first person who gets there, tell me that you did it, and that's what it is. That those points are present.
They're present.
They're present, okay? So that tells you what we've done. And remember when Braden suggested you got to cube this and all this? If we had made some kind of mistake here, we would have seen this not be right, then we would have been able to figure out something else. Right? Okay? Now the way I've set up the packet is I set up page 1 and page 2 to be previewed today. And so Monday we're going to look at pages 3 and 4, and it's kind of in sync with where these things are on Canvas. So people not here can get to these and have a class video. So we're just going to be able to stop right here today, all right?
Nice.